Hello students, now I will start the sixth lecture of motion in plane, which is related to the scalar product or dot product. The scalar product of two vectors, vector A and vector B, is simply the product of its magnitude with the cosine of the angle between them. Let vector A and vector B are two vectors. Then A dot B equal to magnitude of A into magnitude of B into cos theta. Now the scalar product of two vector is always a scalar, that is simple a number, no direction. If these two vectors are parallel, that means theta equal to 0 degree, then A dot B equal to cos 0, that equal to 1. So A dot B equal to AB, that is the maximum value. And if they are perpendicular, theta equal to 90 degree, then cos 90 equal to 0. So A dot B equal to 0, that is the minimum value. And if they are in the opposite direction, then A dot B equal to minus of AB, which is maximum negative value. Okay, and if theta is the acute and obtuse, then A dot B obviously will be positive and negative. Now the properties of the dot product. The dot product is commutative. That means A dot B is always B dot A, and it is distributive. A dot B plus B equal to A dot B plus A dot C. And if you take the dot product of vector itself, that means the angle between two vectors is 0 degree. So A dot A equal to only product of the magnitude, that equal to A square. In case of unit vector, let I, J, K be the unit vector along x axis, y axis and z axis, and this angle equal to 90 degree. So what is the value? I dot I equal to 1 into 1 cos 0 degree, that equal to 1. Okay, so dot product of the unit vector itself equal to always 1. And if the dot product equal, if you take in the u I dot j, okay, that means the angle is 90 degree, so it will be 0. So I dot j equal to 0, j dot k equal to 0, k dot I equal to 0. Suppose A1, B1, C1 are the component of vectors along x axis, y axis and z axis for vector A, and similarly A2, B2, C2 with the component of vector along x, y, z respectively of vector B. Then A dot B, here you see we are getting only the product of unit vector of itself equal to 1, otherwise all are 0. So obviously these and this product will be there. That means the product will be A1 A2 plus B1 B2 plus C1 C2. Some points you have to remember for doing the numerical. Now if two vectors are there, you have to find out angle between them. Then you move to the dot product. So A dot B equal to, you know that magnitude of A into magnitude of B cos theta. So what will be cos theta? Cos theta equal to this formula. And if it is a component form, then it will be this formula. Okay. With an example we are explaining. Suppose two vectors, vector A and vector B are there. You have to prove these are the mutually perpendicular. So A dot B, you take the dot product. Okay. So this is 2i minus 3j plus k into I plus j plus k. Only the unit vector product will be there, otherwise all the vector product will be 0. So this formula will be 2 into 1 minus 3 into 1, 1 into 1, and that will be equal to 0. So cos theta equal to, as it is 0, therefore cos theta equal to 0. So theta equal to 90 degree. It is 0, so cos theta equal to 0, theta equal to 90 degree. Now another thing, see, suppose this is a vector A. Now we have to find out the component of A along B. What is the component of A along B? What will be? This is A cos theta, magnitude of A cos theta. Now you know that A dot B equal to A magnitude of A, magnitude of B, cos theta. So what will be A cos theta? This by magnitude of this. Okay. With an example, we explain that one. Suppose I, j, the unit vector along x and y axis. What is the magnitude of I plus j, and component of this vector along I plus j? So what is the magnitude? Magnitude, you know that formula, a square plus b square plus 2ab cos theta, as ijk angle is 90 degree. So it will be root 2. This one is 0. And tan theta equal to 1 by 1, that equal to tan 1, that is theta equal to 45 degree. Okay. Now what is the magnitude of A and B? With that, we know this formula. Okay. So simply vector A equal to this one, vector B equal to this one, magnitude of this equal to vector A, this one. So d is into this divided by root over of magnitude. So this is 5 root 2. Another is that if magnitude of A plus B equal to magnitude of A minus B, then A and B are perpendicular to each other. Okay. And if vector A minus vector B equal to vector A minus vector B, then there are equal magnitude. Okay. In a application point of view, if we go to the mechanical work equal to, this is scalar quantity, work is scalar quantity, and it is the dot product of two vectors, force and displacement. Okay. So if one example is there, if force is this Newton vector form, and it is displaced 5 meter along z axis. Z axis means unit vector is k, so displacement vector will be 5k. Then what will be the work? Work equal to F dot S. So simply here all the products other than the k will be 0, only 3 into 5, so it is 15. Thank you.